What is typecasting? Typecasting means converting one type to another. This typecasting is also called as type conversion, type coercion, or type juggling. I'll talk more about this. Basically, trying to convert one form to another. I would say trying to convert a wrong form into the right form. We also have, you know, CSR activity going on, corporate social responsibility activity, which is going on. And as part of the social responsibility, corporate social responsibility activity, if we come across as 360 digit MG, if we come across any child labor, we are going to help that kid out and we're going to put that kid into the school and we'll ensure the end-to-end education is taken care of. So why did I put that example here? We put that example because when you load the data set into Python, Python just understands numbers, that's it. It just understands the numbers which are there in your data set. But sometimes those might be wrong. Python might have incorrectly interpreted the data types. You need to convert that into the correct format. And that is what we are doing here. Any child labor, don't support. Put them into school. Right. In that way, do your typecasting. If something is wrong, correct that. Now let's understand using data sets. Numbers in your data set. When you load them into Python, either Python would say that those numbers are integers. It might say integer 32, or it might say integer 64. Or when you load the data, it might say it is float 32, or it might say it is float 64, integer or float. Integers means numbers without decimal values. Float means decimal values. For example, I'm talking about float examples here. 2.16, 3.19, 2.3, so on and so forth. If you have decimals, then they are called as float values. 32 or 64 is based on whether you are using a 32-bit machine computer or a 64-bit machine. Whenever you enter anything, or when you try to use any, any window or any application on your machine, or when you use your keyboard, there are bits which are passed to the operating system. If there are 64 bits which are passed, that means your operating system can handle more data, right? Even if you have more data, it can handle. 32-bit means it can handle less. That's it. Same is the case with integer also. Integer 32 or 64, it works on a similar fashion. Integer examples are like 3, 6, 2, 1. Without any decimal values, they are called as integers. In majority of the latest computers, you have 64-bit machines with 64-bit operating systems, right? So that's what it means. The more you can save and more you can process, the more bits you would have. And also, when you have non-numbers, that is categorical data, when you load this categorical data into Python, Python will start reading that categorical data as object. So the data type of categorical would be called as object within Python. And the data type of numbers would be either integer or float. When we load into Python, this is what happens. We look at it. We look at the data types and try to understand further. So let me go to the practical aspects of it. And let me run the code and explain further about typecasting. So let me get to pre-processing here. Once again, whatever you write after hash, either you have multiple hashes or not, it doesn't matter. But then if you have a single hash, that's good enough. And, everything which comes after that would be treated as a comment. Here also after hash, whatever comes would be called as a comment. It will have no influence on the output. And whatever is available here, I wish to remove that because all the, data which is available here would consume some memory. So if I just click on this delete icon and click on yes, everything would be gone. I press Ctrl L here so that the console is clear. So I'm going to once again import pandas as PD. Pandas has data manipulation capabilities. Data manipulation not in the inappropriate manner, and don't take it as a negative term. Data manipulation means, for example, loading the data, right? Rearranging the columns, adding multiple columns, combining two data sets in that way. So we import pandas as PD. Then pandas dot read underscore CSV. So this is a function which will help you read the CSV file. And within the double quotes, you give the complete path of your data set along with the name of the file and extension. So I'll go to the data sets. There is a data set called as ethnic diversity. I should just copy that and we would paste it here. So that's the complete path. So we have the library. In that library, you have an inbuilt function. Inbuilt means someone else has already written and we are using that. And within the brackets and double quotes, you're giving the complete path and the name of the file and extension. Using this assignment operator, you're assigning it to an object called data. Let me run that. And then when you say data.dtypes, so even before that, if you look at this, this is a data frame which contains 310 rows or observations. Rows or observations or samples or examples or entries all mean the same. And we have 13 different columns. Columns are also called as features, right? Or variables. Okay, so you have this data set. If someone asks you on what is the dimension of your data set, you have to say that I have 310 rows and 13 columns. When you say data, go to data over here and D types, you want to know the data types of each and every column. So if I were to double click and open that, you have employee name, you have employee ID, position, state, zip code, so on and so forth. You have a bunch of things which are available. Employee name is categorical data. Names would be categorical. Categorical data would be loaded as object within Python. Now, employee ID, though you have numbers, These are actually categories. Employee ID is used to tag the name of the employee. You cannot say, let me take average of all the employee IDs. What would that give you? You cannot say, let me look at the variation of the employee IDs. What would that give you? Nothing. These are just identification values for each and every employee. This also should ideally be an object. But Python doesn't know, right? That employee ID, okay, I see employee ID. Though you have employee ID number 1, 2, 3, those are not numbers, those are categories. That kind of intelligence is not built into Python. Hence, we as humans should figure out what are the columns which are loaded inappropriately. An employee ID is inappropriately loaded. Then you have position, you have state, you have zip code, you have gender, so on and so forth. Even zip code, each zip code refers to a location. Just because you have numeric data does not mean it is integer. This also should be an object ideally. Then marital description, citizen, so on and so forth. Salaries, let me look at salaries there. Oh yeah, salaries are represented in decimal format. So anything which is represented using decimal value would be considered as a float. Why 64? Because this is the latest computer. It has a 64-bit operating system. When it comes to age, these are also numbers, but then you do not have decimal values. Hence, it is treated as integer. Then race is an object. Overall, you have majority objects. So hence it's telling that majority of your data types are of type object. So employee ID should have been object, but then it is showing as integer. Zip should have been object, but this is also showing as integer. So it is your responsibility as a data scientist to perform proper data cleansing. So if you have more lines of code, my dear friends, more lines of comments, then you can just type 3 double quotes. And within those 3 double quotes, you write your entire text. So you're saying that employee ID is integer. Python automatically identifies the data types by interpreting the values. Okay, as the data for employee ID is numeric, Python detects the values as integer. But then from measurement level standpoint, we have nominal data. Then we have ordinal data. Then we have interval data. And then we have ratio data. When you look at that, you know that employee ID is nominal because it is an identity for each employee. Okay? If we have to alter the data type, which is defined by Python, then we use as type function. Okay, we use as type function. Even if, for example, here, even if the employee ID is sorted in a sequence, still it would be numeric only. Whether it is sorted in a sequence or not doesn't matter. Python would still consider that as a numeric value only. So data.asType, if I were to say help of data.asType, if you do that, it would give you a lot of information, right? On from which type to which type do you want to convert? Okay, do you want to convert to date and time, to a numeric value? Okay, what do you want to convert? Okay, into which type do you want to convert? Do you want to convert something into an integer? Okay, or do you want to convert specific columns as integer? Okay, so on and so forth. You know, all these typecasting things are available. You can also convert multiple columns into integers. You can convert something into a categorical data, or you can convert that into objects. And there's a lot of help available out there. But then for us, if you want to convert employee ID, which was earlier, um, being loaded as an integer, then you just say, go to data. Okay, go to this data. Then go to employee ID and as type, that means convert that as string str, and then load it back into this. Load it back into data.employee ID. Let me run that. And then when you say data.dtypes, you get the data types. So employee ID, which is converted as object. So earlier it was integer. If you observed it carefully, earlier it was showing as integer, which was inappropriate. Now we have done we have taken a corrective measure, and now it has become an object. For that case, even zip code, right? So you might say that, let me do one thing. Let me say data.zip, data.zip, okay, dot as type. So as type. So you're saying go to data, go to this column called zip, convert that as type string. str means string. That means it would make that as a categorical data, and this would change from integer to object. So once you do the typecasting or coercion using assignment operator, you're assigning it back to the same data set. You're saying, okay, let me go to data, let me go to zip, and then replace it. Right? And then if you say data.dtypes, data types, if you were to look at the data types now, zip also got converted. As a practice, you can also do this. You can say that we have salaries, which are obviously float values, because you have salaries which are represented in decimal values. Now, if you convert this, okay, into integer type, what would happen? So I'm saying go to data, go to salaries column here, okay, and convert that as integer. It doesn't float, means it has decimal values. If you convert that into integer, what would happen? Let me run that. And you're storing it back in the same column. Now, if you look at the data types, you get to see the result. Oh yes, salaries have become integers now, but let's see what happened to that column. Oh yeah, all the decimal values are removed now because you converted that into from float, you converted that into integer. Now you have age here. If you were to convert that into a float, you can do this. You can always say, okay, let me go to data. Let me go to the column called age, and let me convert that into a type called float. Now it is integer, you're converting that into float 32 format. If I were to run it, and if I double click this, you see that now you see that .0, .0. So you converted the integer format into float format. 32 means 32 bits. 64-bit would obviously be faster. Anyways, So earlier, age was integer, now it got converted to float. So what do you mean by typecasting? Typecasting means converting one data type to another. This is called as typecasting.